Introducing PolyCast, a new solution for industrial metal casting. PolyCast is a new filament specially developed for the casting industry. PolyCast has excellent printing characteristics and features balanced mechanical properties with no warping or heated bed required. Easily remove the raft and support from PolyCast models. With experience gained from Poly Support, we have fine-tuned the interlayer adhesion of PolyCast to offer quick and easy removal of support and raft, speeding up your production process. After printing PolyCast, you have the option to polish your model inside the polisher. PolyCast is the second filament to feature in the Polymaker polishable family. The ability to smooth the layers on your model is a hassle-free post-process that will prepare the surface quality of your model, optimizing the part for metal casting. Once your parts are printed and polished, we move to the metal casting foundry to attach the 3D printed parts onto their wax trees to prepare them for moulding. Now the investment moulds can be built up. First, the PolyCast parts are dipped in a ceramic-based slurry. This foundry uses a fully automated moulding system that rotates the parts for an even coating. The printed models receive a series of dippings in different viscosity liquids to build up the initial wall of the mould. This first layer is the most critical, as this will be the contact surface once the molten metal is cast. The models are now showered in a very fine silica-based mixture. This strengthens the mould and speeds up investment drying time. The moulds can now travel through the foundry to the next automated conveyor. At this stage, the moulds are dipped again, followed by another particle shower. This process is repeated until the desired wall thickness is achieved. For stainless steel, a wall thickness of 30mm is sufficient. This process can take 2 days as the moulds traverse through the inner matrix of the foundry. The moulds are then fired in the kiln at a temperature of 900 degrees Celsius. This fully cures the investments and prepares them for the casting. This is also the process of burning out the original PolyCast model. PolyCast has been engineered to produce a very clean burnout that can rival the traditional wax process. PolyCast has an exceptional flow rate, and any PolyCast trapped in the mould is vaporized very cleanly. Once the moulds are fully cured, they can be removed from the kiln and left to cool. The moulds are then given a quick rinse to remove any leftover PolyCast residue, leaving a smooth, clean surface, ready for the casting. These moulds will then be reheated before the casting process begins. The stainless steel is then melted using an electromagnetic induction furnace, which induces eddy currents within conductors by constantly changing the magnetic field. Eddy currents create heating effects to melt the metal internally, with no direct heat source, reducing the chance of contaminating the steel. Any scum and impurities are scraped off the surface and discarded off. The stainless steel is heated to 1612 degrees Celsius, and the moulds are preheated to 1300 degrees Celsius. Now the casting process can begin. Individual moulds are removed from the kiln and held below the furnace. The operator then pours the molten steel into the investment moulds. The moulds are then left to cool naturally on a conveyor belt. Once cooled, the steel can be removed from the mould. This is done using a pneumatic jack, which shakes the brittle mould from the cast. The castings then travel to a different part of the foundry to have their sprues and their risers removed, producing a finished metal part. Let's take a look at some of the investment moulds next to their cast metal parts. Using the 3D printed turbofan in this process greatly decreases the lead time of creating complicated tools necessary to produce traditional wax patterns. With our method, you can eliminate the tooling and wax stages from this method. Our method lends itself perfectly to more complex geometries and short production runs, enabling designers and engineers to push the boundaries of what is possible to cast. This will in turn lead to ever more efficient machines, producing a brighter future for everyone.